Hello everyone. Today we will be discussing Semaphore. Before we can discuss Semaphore, we first need to understand one of the problems in synchronization, which is the dining philosopher's problem. What the dining philosopher problem illustrates is that basically there are 5 philosophers sitting on a rounded table. The philosophers can be in 2 states, the thinking state and the eating state. These 3 philosophers right here are on a thinking state. Whenever the philosopher is on a thinking state, they do not interact with the other philosophers, just minding their own business, thinking about something. But when a philosopher is hungry, they are now on the eating state. What they do is that they eat the food that is in the table in front of them. The problem here is that whenever a philosopher is hungry, they need to use 2 utensils that is in front of them. They cannot eat with just one, but they need to use 2, the utensils that is on their left and on their right. So let's say this philosopher is on an eating state, so he needs to use this utensil and this utensil in order to eat. Then let's say at the same time the philosopher next to him is also hungry. However, he cannot use this utensil because this philosopher is using it at the meantime. So our goal is that we need to make sure that there are no philosophers that are adjacent with each other should eat at the same time, or else we are going to have a problem, and that is the dining philosopher's problem. One of the techniques to solve this problem is, that's right, this is where semaphores comes into play. A semaphore is a compound data type in which it contains 2 fields. One is a non-negative integer and the other is a queue process. At this point, Mr. Ejem will continue to discuss the semaphore code.
So, good day everyone. So let us proceed to the part where we are going to show you on how do we use postfix semaphore in C language using Ubuntu terminal. So first things first, we are going to open the desktop terminal by simply right-clicking the screen and then opening the terminal. And then you can see here we are in the desktop directory. So inside here we are going to create a C file. So in order for us to create a C file, we're going to simply use the touch command and then the file name that we are going to use. So in our case, we are going to use activity4 or act4.c. So as you can see here in the desktop, there is a file name called act4. So inside the activity4.c, we are going to simply paste a program that is going to be used for our demonstration for semaphore and postfix semaphore in C language using Ubuntu terminal. So in this program, we have a total of 4 preprocessors directive, which includes the #include stdio, which enable us to use simple input and output functions such as the print function or the printf function. The next one is the #include pthread.h or pthread header, which enable us to use threads, because in this program we are going to use threads. And the next one is the #include unistdh or header, which enable us to use the POSIX operating system API. And then the #include semaphore.h, which will enable us to use and declare semaphore functions. So these functions includes the semty, which enable the data type semty, which enable us to declare semaphore, and then the semWait, which locks a semaphore, the semPost, which will release the lock semaphore or signal the lock semaphore or signal a semaphore, the seminit, which initialize a semaphore, and then semDestroy, which destroys a semaphore. So as I said earlier about this program containing threads, since we are using the #include pthread header, So in this program, there are a total of 2 threads that are going to be created. The first thread will be sent to the semWait state, and then after that, after acquiring the lock, the first thread will be put into sleep for 4 seconds, and after the first thread was created, there will be a 2 seconds delay before the second thread will be created. Thus, the second thread will not enter immediately after it is called. It will enter only after 2 seconds it is called. So that's all for the explanation for this code. Now we are going to start running the program. So now we just need to save this file, so in order for us to run the program. So let us go back to the desktop again. So run the terminal, and then so in order for us to be able to run the program, we must first compile the program. So we can compile it by gcc the file name, which is the act4.c, and then minus lp thread, and then minus lrt. So as you can see here in the desktop, we have another file called a.out. So that is the compiled file for our C file, which is the activity4.c. So in order for us to call it, we just simply do the dot slash the file name, which is a.out, and then simply enter. And then as you can see here, this is the output. So entered, it was delayed for 4 seconds, and another 2 seconds before the final thread. So final thread to be called. So as you can see here. So that's all for this activity 4 for our operating system. Goodbye. Thank you.